For lab 4, there are three parts. For part 1, we need to perform page link for a data set we download from Kaggle. And in order to do that, I load a data frame in and create a vertex and edge. The vertex is the member ID and the name, and the edge is the member 1 as I renamed to as source, member 2 as the destination, and I use the we as relationship. Then I construct a graph. With the graph construct, I can then perform the page link. And as that finish, then I can see the page link from the vertex and the weight between source and destination from the edge. And here's how I can run the Spark Submit for part 1. So here's the member IDs and that's the page link. And here's the weight between the source and destination, which is the member 1 and member 2. For part 2, we need to using 3 machine learning model, and they all look very similar. The only difference place where I use the models. So for naive base, and this one doing the naive base, this one doing the decision tree, and this one doing the random forest. So in order to do that, I need to create Spark context, and I also like to set a log level to error. I define the input path, then load the data in. Then I rename the social drinker to label, and using these 4 columns as my result set. And in here, I try to see if there's a strong correlation between social drinker and this distance from resident to work, son, and pet. Then I also cast the label into a double type in order for the metric stuff work later on. And in here, I use a vector assembler to construct the distance from resident to work and son and pet into one single vector, and use that as the feature columns. And in order to measure accuracy of the data, I use in cross-validation. So I split the data with 60% be the training, 40% be the test data set. Then in here, I construct the models. And then as the model got constructed, I feed the model with the training data set. So at this point, the model is ready. Then for cross-validation, I can then feed the model and transfer against the test data set. So this is my prediction. And to measure the accuracy of the models, and that's what I did in this code block. And this will show the accuracy of the models. Then, as one more step, we need to generate a report based on metrics. So in here, I can check the confusion metric, and then I can see the precision, recall, and F measured. So let's do the naive-based models first. Then we can do the decision tree. As you can see, the accuracy for my base is about 0.66. Then let's do one more. And this is from decision tree. From the decision tree, the accuracy is 0.098%. And this one will do a random forest. And as you can see, the random forest has even higher accuracy, is 0.99, so it outperforms the other two. And for part 3, we need to do Spark streaming. and we connect to a Twitter streaming as well. Then we can do the word count. And I create a function called violate tweet to measure if the tweet is valid. So if the tweet contains a key which is equal to delete or limit, I can check as the false. Otherwise, it will return true. Then I create a Twitter streaming listener, and basically, if there's a valid tweet, then I send this tweet to the socket and encode the tweet as UTF-8. And in here, and then I basically create a socket and with sleep of 3 seconds and listen for 3 seconds. Then I construct the tweet with the connection to the socket. Then for the Spark streaming, I construct Spark object first. Then I construct the streaming context with 3-second intervals. Then I also define the output data format as a name tuple. So it will always contain data, and tag will be whatever the token we have passed for the word count, and that's the count or frequency of what showed up. So in here, I'm using the streaming context to listen on local host with port 8000. Then I do a flat map with each line and split each line with empty space. With the token generated by this point, I then map each word with lowercase to a occurrence of 1. And for reduced phase, I basically summed up all of the count generated by here, and then map the output to the name tuple I created and put in output. And this basically just start a Spark streaming and wait for terminations. Let's start streaming on the lab from Twitters. Then I can start a Spark streaming on the right. And that's the occurrence of the word and their frequencies. Thanks.